1, make sure that we can easily convert from exponential to logarithmic functions. We want to 2, be able to evaluate logarithmic functions without a calculator. And 3, use logarithmic functions to, well, be able to solve logarithmic functions, period. Okay? So, to start out, we first need to know what a logarithm function is. So the logarithm is the inverse of an exponential function. So just like addition and subtraction are inverses of each other, multiplication and division are inverses of each other, squaring and a square root are inverses of each other, cubing and a cube root are inverses of each other, logarithms and exponentials are inverses of each other. So to solve an exponential equation, you're going to need to convert it to logarithms. To solve a logarithm equation, you're going to have to convert it to exponentials. You just do the inverse of each other, just like you do inverses when you solve a normal 2x plus 1 equals 5 equation. Okay? So, this is the notation that you really need to make sure that you've got under your tool belt. If you had a logarithmic equation of the form y equals log, and we call this base A, so base 9, base 2, whatever the heck the number is there, of x, can be rewritten exponentially with x being by itself is equal to a to the y. So the way that I always remember it is the base of my log, which looks like it's kind of in the basement. The base of my log becomes the base of my power. Right? So this is your base, that's your exponent. So if my base is a, then my base over here, my power is going to be a. My exponent of that base becomes whatever is on the side that's by itself. Because remember with inverses, we kind of just flip-flop the x and the y. So the y becomes the exponent, the x goes by itself. So we ought to be able to go between those two conversions. So sometimes I like to think about a logarithm as an exponent. Okay, so the expression y equals log base x represents the exponent to which base of a must be raised to obtain x. And that's just in words, if you want to think about it as in words. So think of a logarithm as an exponent. The expression y equals log base a of x represents the exponent to which the base of a must be raised to obtain x. So if I see this, I'm thinking, well, what am I going to take a to what power to get to my x? Do I square a to get to x? Do I cube a to get to x? Do I take it to the 4th power to get to x? Do I take it to the -1 power to get to x? What power do I need to take a to get to that x? Okay? All right, so let's do some quick conversion. Oops. Yeah.
Isn't this kind of the same stuff that we did on the Adv Section too? With like the 3x or whatever.
Like trying to make your like bases?
Yeah.
Yeah. Hi.
Hi.
Who are you looking for?
This is for you, Scott.
Thank you.
Thank you.
All right, we good now? All right. So, if we had the exponential equation, 3 squared equals 9, we want to rewrite it into logarithmic form. What is the base of that whole entire power? 3. So that's going to become the base of my log. So it's log base 3, and then we put the 9 next to it, and then throw my exponent off to the right. So this is the conversion back and forth between exponential and logarithmic. So I'm thinking 3 to what power is 9? 2. 3 squared is 9, right? So reconverting. Your base goes into the basement. Your exponent goes to the right. What's number by itself goes next to the log. So you need to be able to easily convert between exponential and logarithmic forms, both ways. If we had 10 to the 5th equals 100,000, what would that look like in logarithmic form? So it would be my base of my log. Log base 10 will be the number attached to that. 100,000 is equal to 5. So again, we're thinking 10 to what power is 100,000? My answer would be 5. Now, a lot of times when you have a base 10, we call this the common log. So a lot of times you will see a log with no number in the base. So you could see it just like this. If we do not see a number, so if no number, then we are assuming 2 m's, 1 m, assuming the base is 10. Okay, because we call that the common log. Which if you look on your calculator, there is a log button on your calculator. And if you press the log button on your calculator, it's going to use base 10, because that is our common log. Okay, so if no number is there, then it is 10, because our common log is a base 10.
Will we like lose points or anything if we forget that on a quiz or tests?
Yeah,
Okay.
you will. So you need to make sure you remember that.
So basically, if it's log base 10, we don't write 10.
Right.
That's what
I mean, if you do write the 10, you won't lose points for that. Is that what you meant?
Okay.
Yes. No. If you put the 10 there, you will not lose points. If you do not remember, like if I gave you this and I said rewrite it as exponential, and you don't remember what the base is,
Yeah,
right.
If we left the 10 in there, we would.
Correct. That would be fine. All right. All right. So we've got our conversions. Hopefully, let's do one more. So if I had 4 to the negative 3rd power equals 1/64th, that would be log base what? Log base 4, the number attached to it would be 1/64th is equal to negative 3. Okay,
I thought it was 164, and I was very confused.
1/64th. So 4 to the negative 3 power is 1/64th. Okay, so why do we care? What's the purpose? Well, we want to be able to solve both logarithmic and exponential equations. Eventually where we're going to be going is we're going to get to exponential equations that we can't make like bases on both sides like we did on our quiz today, so that you can't use that method to solve for your x and the exponent. So you're going to have to be able to use logarithmic equations to solve it. So before we can get to that step, we have to be able to solve just basic logarithm equations, which is what we're going to focus on today. And then we'll slowly keep making them a little bit harder as we go throughout the sections. So, log base 4 of x is equal to negative 2. I need to solve for x. It would be very lovely if my x was over here, because then I could just think 4 to what power is this number, but that's not the case. So because it's in logarithmic form, to solve any equation, you always do the inverse of whatever the operation is that is occurring. So the inverse of a logarithm is an exponential. So can I convert that into exponential form? What would be the base of my power? 4, what would be its exponent? And then on the other side would be x. Well, that's a pretty easy equation to solve. What's x equal to? 1/16. Good. So 1/16 is equal to x. And there's our answer. Make it fancy, put set notation around it. Okay? Not too crazy? All right, let's do another one. Log base 1/2 times 3x plus 1 equals 2. So my base of my exponent is going to be 1/2 to what power? To the second. And we're going to equal that to 3x plus 1. All right, we can solve that. We're going to have to deal with fractions, and that's okay. So 1/2 squared is 1/4 is equal to 3x plus 1. Subtract 1, which is really 4 over 4. So I'm going to get a negative 3/4 is equal to 3x.
So it's negative 1/4 equals x.
Divide by 3. So that gets me negative 3 over 12, which is negative 1/4 is equal to x. Yep, so negative 1/4. Make it fancy, put it in set notation. Gets us our answer. Okay. Got that? All right. How about log base 49 cube root of 7 equals x? This one's a good one because this brings back some other stuff we have. So it's going to be a base of what? 49 with an exponent of x is equal to the cube root of 7. All right, well now this is a little bit different. Now my x is still in the exponent. So now let's think back to what you just did on the quiz. The only way we know right now to solve exponential equations is to try to make like bases. I can make like bases here.
Cube both sides first to make it 7 and a 3x.
Sure, you could do that. We can go with that. I would have made that a 1/3, but sure, we can do that. So Carrie's saying if I would cube this side, then I would just have a 7, which means if I cube this side, it would just become 49 to the 3x.
Yes, and then 7 is the square root of 49, so it's just 49.
No, now make a like base. So my like base is going to be a 7 here.
With 6x.
So 7 squared times the 3x. Good. I'm going to just write it all out. Then we have a 7 to the 1. So 7 to the 6x is equal to 7 to the 1.
6x equals 1, x equals 1/6.
Good. So 6x equals 1. X equals 1 over 6.
And you're done.
Or I would have went, me personally, because I'm not afraid of fractions. That's totally fine what you just did there. I would have did 7 to x is equal to 7 1/3. Which when I divide by 2, I get to the 1/6 too. Because 49 is the same thing as 79 squared, and then just attach the x to it. So either of those would work. They both get you your answer of 1/6. Okay? Can we solve equations?
Yeah.
I think I threw some quadratics on your worksheet, but you guys can easily do quadratics. The only thing with quadratics is, let's quickly do one. Let's do log of 3x squared plus 2x minus 4 equals 0. So what's my base going to be of my exponent? There's no number there. We assume that it is 10. So it's going to be 10 to the 0 is equal to 3x squared plus 2x minus 4. What is 10 to the 0? 1. So that becomes a 1. Since it's quadratic, I'm going to move that 1 over to the other side, which will get me 0 equals 3x squared plus 2x minus 5. Let's see if it's factorable. 3 times negative 5 is negative 15. Are there factors of negative 15 that get me to positive 2? Yeah, 5 and negative 3. My leading coefficient is 3, so I'm going to put it over 3. Reduce if I can. 5/3 stays. Negative 3 over 3 becomes a negative 1. So what are my factors? 3x plus 5 and an x minus 1. So what are my solutions? Negative 5/3 and a positive 1. Now here's the trick. When you get two solutions, you cannot have a negative number attached to a logarithm, okay, because it's not possible. So we have to make sure I get positive values for both of these. So let's check 1 first, because that's easy. So if this becomes a 1, that becomes a 1. I have 3 plus 2, which is 5, minus 4, which is 1. Does that make sense? If I had, come back, log base 10 of 1, is that equal to 0? 10 to 0, is that 1? Yeah, so that one works. But now let's plug in negative 5/3, and I'm going to use my calculator to evaluate that. So 3 times negative 5/3 squared plus 2 times negative 5/3 minus 4 gets me 1. So does that one also check out? Yes, so they both are solutions. So you just need to be careful to make sure that neither of those gets you like a negative 1, because then that would not work out. All right, so the last thing we have to do is just evaluate simple logarithms. So I'm going to skip through these properties because we don't need them. So could you evaluate the following mentally? Log base 7, 7. Equals what? So now again, think about it. 7, your base, to what power is this number? So 7 to the 7 is going to be 1. Right? So if I had log base square root 2 square root 2, what would that be equal to? 1.
You have log base infinity to infinity.
That won't be a thing. What if I had log base 7 of 0? What would that be equal to? Actually, no, not of 0. I didn't want to do that. I did it backwards. Log base 7 of 1.
That would be 0.
That would be equal to 0, right? I did mess it up. Put the 0 in the wrong spot. Because 7 to the 0 is 1. So if we had log base square root 2 to the 1, that would be equal to 0. What if I had something like, can I erase this? So scroll up. What if you had to evaluate log base 4 of 32 really quickly in your head? Didn't realize I was that low. 4 to what power is 32?
3.
3? 4 times 4 times 4 is 64, so that's not even right.
Yeah, I was going to say, I'm pretty sure it's not either, actually. It's not 2.
Yeah, that should be a 64, shouldn't it, to get to 3?
I was going to say, I'm
Yeah. All right, questions with any of this stuff? So can you convert back and forth between exponential and logarithm?
Yes.
Can you solve a logarithm basic equation? And can you just quickly